All right, class, so we've been looking at equations similar to this, maybe not exactly like this, in the problems that we've been doing. This should be VO here. All right. Like I said, we've been looking at problems similar to this. We've been solving problems similar to this. Basically, what we've been doing is, for all the problems in this section, is finding the zeros. You did that in algebra. You tried to figure out where some quadratic crossed the x-axis, and that would be here, and finding the zeros. And that's all we've been doing really for this section. I've shown you some different methods to do it. There's factoring, there's substitution, and then there's graphing. Probably the easiest and most reliable is maybe the graphing part of it, and obviously when the numbers are different like they are in this problem, definitely graphing is going to be the way to go. So what we're going to do is we're going to try to figure out how we can graph this to find the zeros. The concept of this problem is we have a batter here. Okay, he's hitting the ball, and the ball is flying up in the air, and it's coming back down, and this distance it travels to this outfielder out here is 300 feet. Looks like it hits him right in the head. Okay, so 300 feet. We're trying to figure out at what angle this ball needs to leave the bat in order for, with a certain initial velocity, they give us as 100 feet per second. Okay, we're trying to figure out what angle we need to be at to get to go 300 feet. Okay, well, let's think of some practical ways we can look at this before we even start the problem. Could the angle be less than 0? No, that doesn't make sense, because that would mean that the ball went straight into the ground, and we're not going to go 300 feet in the air if it goes straight into the ground. Okay, the other angles that aren't going to make much sense are those that are over 90. Okay, because that means it's a pop-up backwards, right? Okay, so we want all of them between 0 and 90. In fact, our answer should probably be quite a bit greater than 0 and quite a bit less than 90. You could probably think of it maybe right around in the middle. So this is a good way to kind of approach this problem. You know that you're getting a right answer if you can get something somewhere between 0 and 90, and probably close to right in the middle maybe. So these are our two angles we're going to use, and it'll probably be just parentheses around them. We're going to be somewhere in between these. So that can help us with our window when we try to graph this. So how would we solve this problem? Well, I would put it right into my calculator. R equals 300. So I would say 300, just to set up the equation, 300 equals 1 over 32. And this is actually the gravity constant, times 100 squared, and this is initial velocity right here, sine of 2 theta. And I would subtract both sides by 200, or 300. Subtract by 300, and then, like I said, this is what I would put in my calculator, because 0, 1 over 32, 100 squared, sine of 2 theta minus 300. If I find the zeros of this equation, that's going to be my answer. Okay, so for the window, could probably go 0 to 20 for y. And then I want you to pause the video, try and figure out what you would put in for these, the x range, to see if you can get a function that crosses the x value somewhere. So it's got to, when we find where it crosses, when we find where this equation equals 0 up here, when we can figure that out, that'll be your answer. So when this equation equals 0, that's your answer. Alright, so hopefully you gave it a whirl. On my calculator, I used 90 degrees because, again, that was our limit from before. And when I do that, I actually get two answers. I get something that looks a little bit like that. In fact, mine goes a little higher than that. Okay, well, what does that mean? I want you to think about that. Why are we getting two answers? Okay. All right. Well, if you pause the video and you're you thought about it. The reason you're getting two answers is because there's two ways to get to 300 feet. You could do more of a line drive, or you could do more of a high hit that kind of ends up going in the same spot. In between these would be 45 degrees, and this would be the max distance a ball would travel with no air resistance. So obviously there's some air resistance here that isn't being accounted for. But if you hit a line drive with the same initial velocity as you hit more of a pop-up, they could both go exactly the same distance. So to find these angles, you would find the zeros, calculate. So one of the angles is 36.9, the other angle is 53.1.